Hello, in this video let us discuss Cramer's rule on a 2x2 matrix. Suppose we have these two equations in two variables and both of them are in standard form. From the previous videos, we have discussed how to solve them using either substitution or elimination method. But we can also use the Cramer's rule or the matrix method to solve them. So we can look at this system of equation as a 2x2 matrix, right? And what are the elements inside? The coefficients on the left side. So first A and then C on the first column. So AC. And then on the other side, BD. Okay? And to find the determinant of this matrix, just apply the basket method. A times D minus B times C. Now, we have what we call dx and dy. Let's start with dx. Dx is like the determinant, but the coefficients of the x variable, we will replace them with E and F, the constant on the right side. Okay? So instead of A and C, we will replace them with E and F. Therefore, we have E, F, and then copy B and D. Such that this is equal to applying the basket method, E times D minus FB. For dy, we will replace the coefficients of the y variable. So B and D will be replaced by E and F. This one. Okay, so A and C, and then replace this with E and F. And again, applying the basket method, we have A times F minus CE. And finally, the x-coordinate of the solution, x, is equal to dx over d, while the y-coordinate of the solution is dy over d. This will be the solution of our system of equation. Now, let us try to apply this concept. Let us solve this system. Okay, so we have system of equations in two variables. So we have to find the determinant first of the left side. The determinant, just write the coefficients. 9, 3 for the first column, 4 and negative 5 for the second column. So 9, 3, 4, and negative 5. Applying the basket method, 9 times negative 5, that's negative 45, minus 3 times 4 is 12. Therefore, the determinant D is equal to negative 57. Okay, next, let's find dx. This time, we will replace the coefficients of x. Instead of 9 and 3, we will replace them with negative 6 and negative 21. So negative 6, negative 21, and then 4, negative 5. Applying the basket method, negative 6 times negative 5, that is 30, minus negative 21 times 4, that's negative 84. Therefore, dx is equal to, this is 114. Next, let's go to dy. For dy, 9 and 3 for the first column, and the coefficients of y, we will replace them with negative 6 and negative 21. Apply the basket method. Negative 21 times 9, that's negative 189. And then minus negative 6 times 3, that's negative 18. Calculate this expression, you will get negative 171. And therefore, we can now find the coordinates of the solution. The x-coordinate is equal to dx over d, which is equal to 114 over negative 57. So dx is rather 114, d is negative 57. And 114 divided by negative 57 is negative 2. For y, we have dy over d. dy is negative 171 over d, negative 57, and just divide, y is equal to positive 3. Therefore, the solution of this system of equation is negative 2, 3. Next, let us try the system. All right, so we have this system of equation. First, let's determine the determinant. 3 and 2 are the elements in the first column, while negative 4 and 5 for the second column. 3, 2, negative 4, and 5. Apply the basket method. 3 times 5 is 15, minus 2 times negative 4, that's negative 8. Therefore, d is equal to, this is equal to 23. Next, dx. Let us replace the coefficients of x. 3 and 2 will be replaced by negative 15 and 13. And then negative 4 and 5. Apply the basket method. Negative 15 times 5, that's negative 75. And then minus 13 times negative 4, that's negative 52. Therefore, dx is equal to negative 75 minus negative 52, that's negative 23. All right, let's proceed to dy. For dy, we will replace the coefficients of the variable y. First, copy 3 and 2 and replace negative 4 and 5 by negative 15 and 13. Apply the basket method. 3 times 13, that's 39. Minus 2 times negative 15, that's negative 30. So this becomes 39 plus 30. Therefore, dy is equal to 69. Now we can solve for the coordinates. X is equal to dx over d. Dx is negative 23. D is 23. Therefore, this is equal to negative 1. While the variable y is equal to dy over d. Dy is 69 divided by d, which is 23. And 69 divided by 23 is 3. Therefore, the final solution is negative 1, 3. Negative 1 and 3. Another example. Okay, so let's say this is our another system of equations in two variables. Let us solve for the determinant. The coefficients or the elements in our matrix are the coefficients. So 4 and 5, and then 8 and negative 1. Okay, 4 and 5, and then 8 and negative 1. Apply the basket method. 4 times negative 1 is negative 4, minus 5 times 8 is 40. Therefore, d is equal to negative 4 minus 40 is negative 44. Okay, next, dx. This time, we will replace the coefficients 4 and 5, the coefficients of x, by 52 and 32. So 52, 32, and then 8 and negative 1. Apply the basket method. 52 times negative 1, that's negative 52, minus 32 times 8, that is 256. Negative 52 minus 256 is negative 308. Okay, let's go to dy. dy is equal to, copy the coefficients of x, 4 and 5, while replace the coefficients of y, 8 and negative 1, by 52 and 32. and then apply the basket method. So dy is equal to 4 times 32 minus 5 times 52. Just calculate this value. Dy is equal to negative 132. Okay, now let's solve for x. X is dx over d. Dx is negative 308, while d is equal to negative 44. Negative 308 divided by negative 44, that is positive 7. And for y is equal to dy over d. dy is negative 132, and d is negative 44. Negative 132 divided by negative 44, that is 3. Which means the solution is the point 73. 73. Let us try one more. All right. Another system of equation, our last example. So let us solve for the determinant d. D is equal to, write the coefficients 6, negative 15, and 3, negative 4. Perform the basket method. 6 times negative 4, that's negative 24. And then minus negative 15 times 3, that's negative 45. D is equal to negative 24 plus 45, that is 21. Okay, next, solve for dx. For dx, we will replace the coefficients of x. 6, negative 15 will be replaced by 12 and negative 2. 12, negative 2, and then 3, negative 4. Using basket method, 12 times negative 4, that's negative 48. Minus negative 2 times 3, that's negative 6. Dx is equal to negative 48 plus 6, that's negative 42. Okay, let's go to dy. For dy, we will replace the coefficients of y. So 6, negative 15, copy 6, negative 15, and then replace this 3, negative 4 by 12 and negative 2. Dy is equal to 6 times negative 2, that's negative 12, minus negative 15 times 12, that's negative 180. Negative 12 plus 180, that's 168. So dy is equal to 168. Now we can solve for the values of x and y. X is equal to dx over d. Dx is negative 42 divided by d. D is 21. And this is equal to negative 2. Y, on the other hand, is equal to dy over d. Dy is 168 over d, which is 21. And 168 divided by 21, that is equal to 8. Therefore, the solution is the point negative 2, 8.